Welcome back to the Walnut.
So find the total number of squares. Straightforward question. What's the advantage of dealing with this question? Well, it is a matrix form, regular matrix. If it's a regular matrix, it's 4 by 4, right? If it is 4 by 4, what would be the answer here? If it's 4 by 4, simple. 4 square plus 3 square plus 2 square plus 1 square. So 4 square, 16. 16 plus 9 plus 4 plus 1. So 20, 29 plus 1, 30. That's it, 30. So 4 by 4 matrix. Now next one. Just take a look at it. A large triangle is divided into 1, 3, 5 pieces, correct? So large triangle that is divided into 5 pieces. 1, 2, 3, 4, 5. So if you take one piece at a time, we can take it as what? One piece at a time. T1, 5 triangles. Then 2 pieces at a time. So 1 and 2 together is a triangle, 2 and 3 triangle, 3 and 4 triangle, 4 and 5 triangle. So 4 of them. So 1 piece at a time, 5. Then we have 4. Then 3 pieces together, we have how many are there? 3 of them. Then 4 pieces together, we have 4 of them. 4 pieces together, we have 2 of them. It goes like that. Of course, counting is possible, but it is time consuming. What's the method? N into n plus 1 by 2. So 5 into 6 by 2, 15 is the answer. Done. How many seconds you need? In order to read the question and understand the question, probably you need 10 seconds. And in order to get the answer, what do you need? Another 10 seconds. So it's 20 seconds question. Look at this question. Interesting. So what is the method or what's the formula here? And while counting is tedious, time consuming. So what's the method? Total number of triangles, that would be n into n plus 2 into 2n plus 1 by 8. That's a formula that we can use. So n is what? Number of triangles on the base which are facing upward, right? So 1, 2, 3, 4 and 5. So 5 triangles facing upward. If 5 triangles facing upward, we have 5 into n plus 2, 7 and 2n. 2n is 10, 10 plus 1 is 11. So 11 by 8. So what is the answer you get? So here it's 35 into 11. 35 into 10, 350. 35 into 11, 385, right? 385 by 8. What do you get approximately? 8. How many times? 8 into 4, 32, right? So, 4 times and balance is 6. 6 and 5, 65. 65, 8, how many times? 8 times in 65, right? Actually 8 into 8 is 64. So 8 times. So 48 point something. So 48 would be the answer. So 48 triangles we have here altogether. Different combinations. Sometimes 1 triangle at a time. Sometimes we may take 4 triangles together. So this case, what are the possible combinations we have here? 1 triangle at a time, we have all these triangles we can count. Then apart from that, we have 4 triangles together. This is another possibility. Apart from that, when you look at this, this 4 triangles, then we have 4 plus 1, 2, 3, 4, 5. So 4 plus 5, 9 triangles together. Then we have these many triangles together. So all different possibilities. So you must be aware of this, but counting is not really practical. Okay, let's go for the next one. How many triangles are there in this figure? So how many triangles? Check it out. How many triangles? This case, when you look at it, the first thing what see here, 1 triangle, 2, 3 and 4. So at a glance we see 4 triangles. But on the top of that, do we have any more triangles here? So if you go for counting method, 1 piece at a time, 1 triangle at a time, we have 4, and 2 pieces at a time. That means 1 and 2 together is a triangle, 3 and 4 together is a triangle, then 1 and 4 together is a triangle, 2 and 3 together is a triangle. So 1 and 2, 4 and 3, 2 triangles, 1 and 2, 4 and 3 at the same time, 1 and 4, 2 and 3, another 2 triangles. So total 8. And any other triangle possible here? Any other triangle? No, that's maximum is 8, right? So we don't have any other answer choice more than 8. So there's no need to bother about is there any more triangle applicable here or not. In this case, it's pretty simple. 8 is the answer. But you know what? Sometimes this question could be a little more complicated. I'll show you. This is what it is. Now, how many triangles are there in this picture? The previous case counting was pretty simple. We got the answer 8. This case, you know what? It is a little more time consuming. How many triangles you have? So if you take one piece at a time, we have 8 of them. Now, if you take two pieces together, how many triangles we have? These two together is a triangle. These two together is not a triangle. Again, these two together triangle. These two, it's not a triangle. And two pieces together, then three pieces together, it's not a triangle. Any three pieces together, it's not going to be a triangle. How about like four pieces? Yes, 1, 2, 3, 4. These four pieces triangle. And the other four pieces, that's a triangle. Right? Anything else? This one and this one. One set, other set. And this four triangles and this four triangles as well. So there are many such possibilities. So when you get a question like this, what I suggest, there is a method, there is a shortcut method. What I suggest is, look at the pieces here we have. So 1, 2, 3, 4, 5, 6, 7, 8 pieces. So we have 8 pieces. How many diagonals do you have? So this is one diagonal, this is another diagonal. So look at the number of triangles and rather than triangles, all these may not be triangles. We are looking at the number of pieces. Altogether, how many pieces we have? In this case, all of them are triangles. So 8 pieces into 2 diagonals. So 8 into 2, 16. So in this case, the answer is 8 into 2, 16. And how about the previous question? Picture was different, right? So this was the picture. How many pieces you had? That case, we have 4 pieces, right? So that 4 pieces and how many diagonals? 2 diagonals. So 4 into 2, 8. Perfectly all right. So that means we can use this method for these kind of questions. Especially a square or a rectangle is partitioned in this pattern. It's mainly applicable for square, rectangle, those kind of shapes. Even for parallelogram, those kind of shapes. This case, rather than a square, that's a rectangle. First of all, we look for the number of pieces here. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. How many diagonals? 2 diagonals. Doesn't matter, it's a square or a rectangle. No issues. We are looking for the triangles here. So number of triangles we have here would be the number of pieces into 2 diagonals. So number of pieces, 8. 8 into 2 diagonals, that would be 16. The answer is what? 16. Let's go for the next one. This one, parallelogram. So how many parallelograms in this figure? How many parallelograms? So let's say the marking would be like this. 1, 2, 3, 4. So 4 small parallelograms are there. At the same time, we need to count the total number of parallelograms here. How do we count it? So probably you remember the method we have used as earlier, counting method. So 1, well, in this case, I don't take P, I take it as, rather than T, I'll take it as P. P means what? Parallelogram. 1 parallelogram at a time. So 1 piece at a time. This is a parallelogram. The second one, third one, fourth one. So 4 parallelograms. And P2, that means 2 pieces together. 2 pieces together, 1 and 2 together, it's a parallelogram. 2 and 3 together, it's a parallelogram. 3 and 4 together, it's a parallelogram. So 1 and 2, then 2 and 3, then 3 and 4. So we have 3 of them. Then P3, that means 3 pieces together. 3 pieces together, 1, 2, 3, parallelogram. 2, 3, 4, parallelogram. How many? 2 of them. So that means 1, 2, 3, 1 parallelogram. 2, 3, 4, another one. So 2 of them. Then 4 pieces together. That means all the 4 pieces together. All the 4 pieces together, how many you got? 1. So ultimately 4 plus 3, 7. 7 plus 3, 10. Total 10. However, to remember what I have mentioned earlier, for triangles, for rectangles, and even for parallelograms, if you have number of pieces and if it is divided into smaller number of exact shape, that means triangles divided into smaller triangles, and rectangles divided into smaller rectangles, and parallelograms divided into smaller parallelograms exactly like this, that case you can use the formula what? N into n plus 1 by 2. So this case 4 pieces. So 4 into 5 by 2. So 10. 4 into 5, 20, 20 by 2, 10. Same answer. So the answer must be 10. That's it. All right, next one. You look at this kind of question. What kind of method can be used here? Let me mark it as 1, 2, 3, 4, 5, 6. So 6 triangles are here. So each one is a triangle. This one is a triangle, this one, and this one triangle as well. So each one is a triangle. So we have 6 triangles. Question is, what's the total number of triangles we have here? This is the line, dividing each side equally. And whether is it really useful for us? Well, geometry, that is something like, that this is going to be a rectangle, those kind of things. But we are not really getting into that geometry part of this. What we are going for here is total number of triangles. So if you go for counting, what is the answer we have? That means one piece at a time. One triangle at a time, we have 6. 2 triangles at a time. Any 2 triangles at a time, do we get a third triangle? Do we get another triangle? For example, if 1, 2 together, we get a triangle. That's true. But 2 and 3 together, it's not a triangle. Again, 3 and 4 together, it's a triangle. 4 and 5 together, it's not a triangle. And 5 and 6 together, triangle. So ultimately, 1 and 2, 3 and 4, 5 and 6. So we have 3 triangles. So 2 pieces together, we have 3 triangles. And how about like 3 pieces together? Any 3 pieces together, do we have triangle? Of course, 1, 2, 3 together is a triangle. 4, 5, 6 together is a triangle. So 3 pieces together, we have 2 triangles. 1, 2, 3 and 4, 5, 6. Any other possibility? Definitely, we have 2, 3, 4 and 1, 6, 5 triangles. So 2, 3, 4 is a triangle. 1, 6, 5 is another triangle. So how many are there? Yeah, it is actually T3. 3 pieces together. So 2, 3, 4 and 1, 6, 5. Again 3, 4, 5, that's a triangle. 2, 1, 6, another triangle. So we have 2 more. And 3 together, 3 pieces together. Now 4 pieces together. So 1, 2, 3, 4. That 4 pieces together, it's not a triangle. How about like 2, 3, 4, 5 together? Not a triangle. 3, 4, 5, 6. No, it's not a triangle. So 4 pieces together doesn't work. How about like 5 pieces together? Doesn't work. Now 6 pieces. All the 6 pieces together, that's a large triangle. So 6 pieces together, we have 1. So ultimately what? 6 plus 3, 9, 9 plus 1, 10, 10 plus 6, 16. So total what we have is 16 triangles. So that's the answer. Do we have any shortcut method for here? Last time we have discussed about like diagonal case, right? If it is rectangles or if it is parallelograms or it could be squares, the number of smaller pieces into the number of diagonals, you may get an answer. So this case, this one, it's not really the diagonal, but if there are 3 of that, so number of pieces 6 into, if you take it as 3, 6 into 3 is 18, but we don't get the answer here. So ultimately, this kind of questions, this method, formula method is not really applicable. You need to really count. Okay, so that is the sum of the questions that requires time. Be aware of that. Next one here. Okay, how many rectangles are there in the figure? How many are there? Look at the number of rectangles here. At a glance, we see the number of rectangles 1, 2, 3, 4, 5, 6. So how many rectangles are there? Each one is a rectangle, right? So total 6 rectangles. So if you go for counting method, this is what it is. So counting method, well, 1 rectangle at a time. So R1. R1, so 1 rectangle at a time, we have 6 of them, 6. And well, 2 rectangles at a time, 2. Any 2 rectangles. So 1 and 4 together, it's a rectangle. 2 and 5 together, rectangle. 3 and 6 together, rectangle. So we have 3 rectangles. Plus 1 and 2 is a rectangle, 2 and 3 is a rectangle. So we have 2 of them. 4 and 5 is a rectangle, 5 and 6 is a rectangle. So we have 2 more. And 3 pieces together. Any 3 pieces together. So R3, that means 1, 2, 3 together is a rectangle. And 4, 5, 6 together, it's another rectangle. So we have 2 of them. Now 4 pieces. Any 4 pieces. Well, 4 pieces together, 1, 2, 4, 5, it's a rectangle. Then 2, 3, 5, 6, that's another rectangle. So we have 2. How about 5 pieces together? R5. Well, 5 pieces. If you take any 5 pieces from here, it doesn't give you a rectangle. So next thing, we have to go for 6 pieces. R6 is equal to 1. All right, so this is what we have all together. 6 plus 3, 9. 9 plus 1, 10. 10 plus 8, 18. So we have 18 rectangles. Is there any other method for this? If it is one single row, you treat it as one single row. This one single row, how many rectangles you have? So how many pieces are there? 1, 2, 3. If it is 1, 2, 3, we can use the method n into n plus 1. So this row, we can take it as n into n plus 1 by 2. So how many you get? N is 3. N into n plus 1. Okay, fine. So n is 3. 3 into 4 by 2. So 12 by 2, it's 6. So we'll have 6 here. And at the same time, we take another set here. So how many you get? 6. So 6 plus 6 is 12. But that's not the end of the story. Now we have to take the third set as well. Third set, which is a third set? Third set means you take these 2 sets together, you take the third set and consider we have 3 pieces here. 1, 2, 3 pieces. If you consider that way, again we can take it as what? 3 pieces. You can take it as n into n plus 1 by 2. So you get 6 more. That means combination of this is 6 more. So ultimately 6 plus 6 is 12. 12 plus 6 is 18. So the answer is 18. And if you count, you get the same answer as well, 18. That's what it is.
Well, if you need to have additional questions for practice, take a look at our website walnuttraining.org.